Hello everyone, thank you for checking out this video. You are with Coach Deathbot from 32 Academy. Next up, question 6. The question says, if P, Q and R are prime numbers such that their product is 19 times their sum. Okay, so the product is 19 times the sum. What is the value of P squared plus Q squared plus R squared? Okay, let's try this number theory question together. So just follow what the question said. Product is equal to 19 times the sum. Okay, because P, Q and R, each of this is a prime number, meaning that one of the three has to be 19, correct? So without loss of generality, let's just say that R is 19. It can be any one of these, right? It can be P, can be Q, can be R, anything. So let's just say R is 19. So the equation would become you substitute R with 19. So PQ is equal to P plus Q plus 19. Okay. If you move P to the left hand side, Q to the left hand side, you will get PQ minus P minus Q equal to 19. Okay. But if I plus 1 on both sides, this is plus 1. So 19 plus 1 become 20. Okay. Notice now the left hand side, you can factorize it into P minus 1, Q minus 1. So the trick here is because we know that P and Q are integer. So try to factorize it, because factorization would help you distinguish what should be the next step is. Alright. So here is equal to 20. What do I mean by the next step is, right now you notice that it's a product of two integers that is equal to 20. So there are only like a few cases. So 20 can be what? 1 multiplied by 20, 2 multiplied by 10, 4 multiplied by 5. Alright. So you can try this possible value out. Since P and Q are prime numbers, okay. So since P and Q are primes, meaning that the only way that it works here is 4 times 5. Okay, so no, it's 2 times 10. Sorry. So 20 is equal to 2 times 10. So P minus 1 is equal to 2, meaning that P need to be equal to 3. Q minus 1 is equal to 10, so that means that Q is equal to 11. And of course, if you do the other way around, meaning that 10 times 2, so you will get P is equal to 11 and Q is equal to 3. It's the same thing, okay? At the end, the question asks you to find, so just answering the question, hence P squared plus Q squared plus R squared. So 3 squared plus 11 squared, and R initially we say is 19, correct? 19 squared. So yep, calculate this out. At the end you should get 491. So the final answer is 491. Moving along, question 7. The question says that n is a 4-digit number with the property that all the digits of n, when added to the number n itself, the sum is equal to 2019. And the question asks you to find the sum of all the possible values of that number n. Okay, let's try this number theory question together. So let's say that n is given as a 4-digit number, alright? So let's say n is equal to A, B, C, D in decimal representation. So follow the question. They say that the number n has the property that when all the digits of n are added to the number n itself, the sum is 2019, right? So this A, B, C, D in decimal representation can be written as 1000A, 100B, 10C, and 1D. Alright, and then add the digits, meaning you have another A, another B, another C, another D. The sum is 2019. Okay, simplify it. 1001A plus 101B, 11C, and 2D is equal to 2019. Notice that A cannot be 0, alright, because n need to be a 4-digit number. If A is 0, n is only a 3-digit number or less. Okay, so A is at least 1. So A can be 1, can be 2, but not 3 and above. Because if A is 3 and above, if A is 3, this alone is already 3003, which is already more than 2019. Alright, so meaning that A is equal to 1 or 2. If A is 1, substitute 1 in, alright, so it becomes 1001 plus the rest, alright, so 1001, put it on the right hand side, so this is what the rest is, okay, 100 of B plus 11C plus 2D. 2019 minus 1001, that will be 1018. Okay, so here more or less the same logic. Okay, B need to be 9, because if B is only 8, this is 808. Even though C is 9 and D is 9, the sum will not top up to become 1018. So here it forces B to be 9. Okay, so when B is 9, again you substitute in, this equation would just become 11C plus 2D, 1018 minus 909, that would be 109. Okay, so same logic. Here it actually forces C to be 9, and yep, when C is 9, D is actually 5. Okay, thus D is 5. So meaning that in this case n is 1, because A is 1, right? So 1995. This is one value of n. That is when A is equal to 1. Okay, but A can also be 2. So let me write here. If A is 2, you substitute it in, so it's 2002. All right, 101B, 11C, and 2D is equal to 2019 minus 2002. So that is equal to 17. Notice B cannot be 1, right? Because if B is 1, it's already 101. So it forces B to be 0. So when B is 0, this is technically 11C plus 2D is equal to 17. Same logic, that will force C to be 1. Thus, D is 3, which means that the value of n is 2013. So there are two possible values of n, 1995 and 2013. To answer the question asks us to find the sum of these possible values. So hence 1995 plus 2013. So the final answer is 4008. Okay, moving on. Question 8. ABCD is a square with the side of 8 cm. E and F are variable points. E is on BC, F is on CD, with the constraint that BE need to be always equal to CF. Okay, so with this variable points, the question asks, what is the smallest possible area of triangle AEF? Okay, let's attempt this question together. So let's say X is that BE and CF. Okay. Because the side of the square is 8 cm, alright, so meaning that this is 8 minus X, and DF is also 8 minus X. This is 8, this is 8. I want to write the area of triangle AEF in terms of X. Okay, and then I can variable X. I can vary X in between 0 and 8 and see what is the smallest. So that would be the steps of my solution later on. Okay, so how to find area of AEF? Notice that this whole diagram is a square, so I know the area of the square. And if I want to find the middle triangle, I need to minus 3 triangle on the sides. Okay? So half base height, this would be just 4x. Half base height, this would be just 8 divided by 2, right? So that would be just 4. 8 minus x. Half base height, this would be x multiplied by x. 8 minus x divided by 2. So area of triangle AEF can be written as the whole square, which is 8 square, so that's 64, minus these 3 areas out. So minus 4, 8 minus x, minus 4x, minus x multiplied by 8 minus x over 2. Okay, after you simplify this expression out, you get x squared over 2 minus 4x plus 32. Alright, so I will attempt to do completing the square. Take half as a factor first, so that would be x squared. Since I take half, meaning this is negative 8x. So if I want to do completing the square, meaning that the third term would be 4 squared. Alright, so that would be 16. So meaning I already have a plus 8 here, right? 16 divided by 2, but that is 8. But initially I have 32, so I need to plus another 34. Okay. Reason of doing completing the square, so now half multiplied by x squared minus 8x plus 16. Yeah, it is a square, so x minus 4 squared plus 24. This square expression meaning that it is non-negative. Alright, it's always greater than or equal to 0. So multiply by half, it's still greater than or equal to 0. Plus 24, so that is greater than or equal to 24. So that means that the minimum area is 24. And I need to check, is it possible? So when will this equal than or equal to can be equal? That is when this can be 0, right? So equals when or when x is equal to 4. So is it possible that x is equal to 4? It's possible, right? X can be anything as long as in between 0 and 8. So the answer to this question is the minimum area is 24. Next, question 9. If A, B, and C are non-zero real numbers with the conditions that A plus 2B plus 3C is equal to 2014 and 2A plus 3B plus 2C is equal to 2014 as well, the question asks you to find the value of A squared plus B squared plus C squared over AC plus BC minus AB. Okay, so let's try. This is what we are given, alright? It's equal to 2014. 2A plus 3B plus 2C is also 2014. Notice that if I take the second equation minus the first equation, I would get 2A minus A, so that's A, 3b minus 2b, so that's b. 2c minus 3c, so that's a negative c, and it's just equal to 0. That means that 0. I square both sides, alright. This is what I have. Opening up, I will get a square plus b square plus c square minus, take minus as a factor, so minus 2 as a factor, right? AB, but because I take minus as a factor, so now it's a minus AB. Let me write behind. And then I have AC. I already take minus out, alright, so it's just AC. Again, BC should be minus, but I already take minus out, so it becomes plus BC. Okay, that means that this expression, the one that the question asks us to find, AC plus BC minus AB, is, well, technically just 2. Alright, so the final answer is just 2. This is actually pretty straightforward question. Okay, question 10. In the diagram below, triangle ABC and triangle CDE are both right triangle, with AC is given as 24 and CE is given as 7, as well as angle ACB is equal to angle CED. Alright, it's all annotated on the diagram. The question asks you to find the length of the segment AE. Okay, so let me draw AE here. So what is this length? Okay, let's try. Answer. So you have right triangle, and you know AE is 24, CE is 7. So in triangle ABC, okay, first probably let's say the angle here is alpha, and here should be also alpha, right? So in triangle ABC, if I want to find AB, that would be AC multiplied by sine alpha, right? But AC is 24, so there's 24 sine alpha. And BC, that would be cosine, right? So 24 cosine alpha. That is triangle ABC. In triangle CDE, I would have DE, that is 7 cosine alpha, and CD, that would be 7 sine alpha. Okay, so first thing first, probably I want to find BD. BD is equal to BC minus CD. Okay, so that would be 24 cosine alpha minus 7 sine alpha. Okay, there first. Alright, so maybe I extend this a bit. So this is also a right triangle, right? So if you use Pythagoras in that triangle AE, maybe here F, alright? This is F, right? If you use Pythagoras in triangle AEF, so AE square would equal to EF square, but EF would equal to BD, right? So BD square, so that is 24 cosine alpha minus 7 sine alpha square plus AF square. But AF is equal to AB plus DE. So AB, that is 24 sine alpha, and DE, that is a 7 cosine alpha square. Okay, expand it and then multiply, expand it and then simplify it. You will get 24 square cosine alpha square, and you also have here sine square alpha. Alright, so take 24 square as a factor. You will get cosine square alpha plus sine square alpha. Same thing for the 7, alright? Take 7 square as a factor. So sine square alpha, and here cosine square alpha. And the 2ab, right, the term 2ab will cancel each other out. Alright, 2 multiplied by 24 multiplied by 7 multiplied by sine alpha multiplied by cosine alpha. Here's a minus, here's a plus, so it will cancel each other out. So this is what we have, but we know that cosine square plus sine square will be 1, right? So this is just 24 square, and this will just be 7 square. 24, 7, Pythagoras triple, right? That is a 25 square. So if you don't, even if you don't remember this, this is small enough to do, right? Square, 24 square plus 7 square, that would be 625, which is 25 square. Okay. So yep, that will give you AE to be 25. We have completed this lesson. Thank you for watching this video. I hope you have enjoyed today's lesson. Goodbye, and see you again in another lesson.
If you would like to learn more from these tutorials, please smash that like and subscribe button.